All right, all right, all right. Good evening to all the grade 12 students. Welcome back, welcome back. Welcome to one more session of your WOC. We have started this series today. That's nothing but most probable board examination type questions. 100% you'll be getting questions from these series students. So basically today we have started the series and this is series 2. So that means series 2 means day 2, the particular thing. Today I have sent in the morning the series 1, that's day 1 questions. So day 2 is following on the same day. So please remember students, in this particular series for your grade 12 board examinations, as you all know, we have 10 chapters, right? Yes, those 10 chapters I'll be covering what topics. First I'll be covering multiple choice questions, very short answers, assertion reasoning type, content based and log type questions, and some important board questions. So all this will be covered for all the 10 chapters. We have almost 30 days, so it will be comfortably done, nothing to worry. But remember, I'll be sending on daily basis two videos. So before we dive into the topic, let me tell you something most important. First important concept is I'll be sending videos, two videos per day. Two videos will be two. So what you're going to do is you're going to purchase one 300 pages notebook and start noting all. And most important thing is sleep early, students, because don't wake late nights, it will disturb your mind. And wake up early. So what you're going to sleep early and wake up early is very important. So as soon as you get up early in the morning, try to revise what videos I have sent on the earlier day, and your work will be done. That's very important. And most important thing is for you all students, I have done 1.7k videos which includes line by line NCRT. So till now, till date, if I have to tell you, I have sent you concept. Like before we go, these questions are waiting for us. So before we go to these questions, let me tell you something important. What is it? Important thing is one shot videos are done from my end, handwritten notes are sent from my end, everything is for free. So please watch everything and come to the series. Let's start without wasting time. So the question here given to us is, we have three aqueous solutions of NaCl which are labeled as A, B, C. Concentration given is 0.1, 0.01 and 0.001 molar. What is the value of Van 't Hoff factor is what they're asking for these solutions in the order. So first of all, let us write the particular solutions and let us understand how it is. First of all, Van 't Hoff's factor for strong electrolytes. So what is the formula, students? Van 't Hoff's factor for strong electrolytes. So Van 't Hoff factor for strong electrolytes, what is the formula which you have learned? The formula is I is equal to total number of ions after dissociation or association divided by total number of ions before dissociation or association. That is what you have studied, right? Let us write total number of ions after dissociation or association. This is after divided by total number of ions, total number of ions before dissociation or association. This is the concept, right? This is right. Okay. Now what did they give me? They have given me NaCl. Let us take. First of all, NaCl, how does it dissociate? It dissociates into two ions. One is Na plus ion and it dissociates into Cl. How many ions are there? So the Van 't Hoff's factor I for this are two ions, right? 2 is a Van 't Hoff factor for NaCl. Now Van 't Hoff's factor basically is independent of what? Yes, Van 't Hoff's factor is independent of the molality of the solute added. You know that, right? Here Van 't Hoff's factor is 2 because of 2 ions. So the basic quantum bit I know is Van 't Hoff's factor, as we have studied earlier, this Van 't Hoff's factor is independent of molality. We don't know, right? Alpha value independent of molality. Okay. Independent of molality of what? Of solute added. Of solute added. Okay, this concept is clear. Now, when solute is added, they asked us for this particular molality, or see, the formula is not talking about any sort of molality, it is talking about dissociation association. So they've given me three different molalities. So now you only tell me what will be the order. Will it be decreasing? Wrong, because it is not dependent. Will it be increasing? Wrong. Will it be more greater? Wrong. So all will be equal, because the reason is Van 't Hoff's factor is independent of the solute added. It depends upon the degree of dissociation only. So the option is I is equal to IB is equal to IC. Perfect. This is the clue there. So remember the clue and write it. Let us go to the next question, students. Let's see. Easy. Which of the following is incorrect for ideal solutions? Okay. Ideal solution is given to me. Okay. So ideal solution, delta H enthalpy is given. Okay, let us not mark. It will get confused. Volume mixing is 0. Delta P is equal to P observed minus P calculated. Delta G is equal to 0. So first of all, how let us understand the concept. So first of all, for ideal solutions, what are the parameters? For ideal solutions, we very well know the parameters. That's nothing but delta H mixing is equal to 0. Do you accept? Yes. Delta U mixing is also 0. All right. Now, delta X mixing is not equal to 0. Now, how can we say this? Let's go to the formula. So basically, what is the formula which is relating? Delta G mixing is equal to delta H mixing minus T delta S mixing. This is what is the concept. Now tell me, when delta G is not equal to 0, as you have seen, see delta here it is equal to delta H mixing minus D delta S mixing. So according to this, delta G mixing is not equal to 0. Now when delta G mixing is not equal to 0, see you're saying it is correlated to which two factors? These two factors. According to the formula only I can say. Now go back to the option. So which is the incorrect option, students? According to this, delta G mixing is not equal to 0. This is a correct option. But what did they give me here? Which of the following is incorrect for ideal solution? Here they have given, see here, they have given delta G mixing is equal to 0. So this is the incorrect option. So the answer is delta G mixing is equal to 0. No, the actual concept is delta G mixing is not equal to 0. Easy? Easy. Let's see the next question. Which of the following is correct? KH increases with increase in temperature. Okay. Solubility of gas in liquid decreases with increase in temperature. Okay. KH decreases with increase in temperature. Okay. Solubility of gas increases with increasing in temperature. So basically, let us first understand the concept. They're talking about what the KH value or solubility. Only two concepts. Let us clear first the solubility concept. Let us see the solubility concept. Now, what is solubility concept? What does it say? Solubility of a gas. So basically, solubility of a gas in liquid. Okay, because they're talking about gas in liquid, I have taken the concept. Solubility of a gas in liquid is directly related to the pressure of gases. Perfect? Yes. All right. So this is one concept of. Now let us go with the Henry's law concept. Same continuing, pressure is equal to Kh into X. You have studied this, right? Yes, pressure is equal to Kh into X, or you take out Kh. Kh is directly related to P by X. P by X. Okay. And what is this? What is P standing for? P is standing for partial pressure of gas. Partial pressure of gas. Okay. What is X standing for? X is standing for your mole fraction. This is also done. What is your KH standing for? KH is standing for your Henry's constant. This is also done. Okay. Now this KH or Henry's constant, what factors it depends? So your Henry's constant basically depends upon nature of gas. This is the first important thing which you should remember. Okay. It also depends upon nature of liquid, which you are taken nature of liquid. Okay. This KH also depends upon temperature, as you have seen. Now, tell me, when I said looking into this equation, can I summarize something? And now, as the temperature increases, KH value also increases and X value decreases. Ma'am, how did you say this? Say this. It is indirectly related, right? When the temperature increases, KH value increases, temperature increases, and X value decreases. Okay. Now, when the temperature is increasing, what will happen to this one, students? Boiling, 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 boiling. The solubility of gas also decreases. Perfect. Now let us go back to the question. This concept is clear. This is a key point which I should remember. Go back. Which of the following statement is correct? So now you only see and tell me. KH increases with temperature. This is correct. That is what we have seen. Correct. Okay. Next. Solubility of gas in liquid decreases with increase in temperature. This is also correct. KH decreases with increase in temperature. This is wrong. Solubility of gas increases. This is wrong. So both option A and option B are correct in this case. Perfect. Perfect. So the formula and relationship is there. That's easy. Let us go to the next question. Maximum amount of solid solute that can be dissolved in specified amount of given liquid solvent does not depend upon. So see here, they've given a clue. Maximum amount of a solid solute that can be dissolved in specified amount of given liquid solvent. Okay. Now, simple, solid solute. So, solid solute, let us see one. Okay. First, we will see which one does not, it does not depend on which one. Let us take on pressure concept because solid, no. So, on solids or rather liquids. So, how much, what is the pressure concept, students? It's negligible. Negligible. The concept of pressure is negligible on solids and liquids. Okay. Because your solids and your liquids compressibility is very less. Correct. It's correct, no? Because when I compress it, it will break. So compressibility is negligible. Now, so when there's no compressibility, pressure concept is ruled out. Pressure, there's no concept of pressure in solids and liquids. So they said maximum amount of solid solute that can be dissolved in a specified amount of given solvent does not depend upon pressure. Easy, easy. Next question. Think and answer. Think. As this page is left empty, think before you mark. Let me say that. Think before you mark. Just use just 2 minutes. Give 2 minutes gap to your brain. It will only give you the answer. Next question. On the basis of the information given below, mark the correct option. So information is in bromoethane and chloroethane mixtures, intermolecular attractions AABB are same as AB type. Okay. In ethanol and acetone mixtures, AA or BB type molecular are stronger, means they're greater than AB type. In chloroform and acetone, AA and BB are weaker than this. So solution B and C follows Raoult's law. Solution A will follow Raoult's law. Solution B will show negative deviation. Solution C will show positive deviation. Okay, now first how should I understand? As I said, case number 1, first option, let me take this page. As I said, when you have similar structure and similar polarity, similar structure and similar polarity, what are they? Similar polarity, they are always called ideal solutions. They are always called ideal solutions. Okay, done. So which is the correct option? They said I have to mark the options which are below A, B, C. So solution B and C will follow Raoult's law. They said I don't know, they've not spoken anything about solution A. We'll see, it is down below, will come. So here they follow similar polarity ideal solutions. Okay, this option is there. I can take this option, right? Because it is already given. They follow Raoult's law. Solution A will follow Raoult's law. For me, it is correct. Okay. Now let us see one more. In ethanol and acetone, AABB. So ethanol and acetone. What is the option, students, in ethanol and acetone? Ethanol and acetone, there is some hydrogen bonding which is seen because of the inbuilt hydrogen bonding. So when hydrogen bonding is there, what type of deviation? They show positive. In positive deviation, what is it? AB interactions are less than AA and BB. Now, what did they give me? They've given me solution A. They've given me AA interactions are stronger, they said. This is wrong, right? This is ruled out. Okay. Let us go to the third concept. In chloroform and acetone mixture, let me use the next page, students. Let us go to the chloroform and acetone. So third option is what? Chloroform. Okay. Chloroform and acetone. What type of mixtures these are? These are non-ideal solutions and there is no hydrogen bond. So what do? They show negative deviations. When they show negative deviations, what will happen? AB interactions are more than AA and BB interactions. Are you right? Yes, this is right. Okay, now I have ruled out all the options. Now you tell me, go back to the option. What did they give? In chloroform and acetone mixture, they are weaker, they said. No, this is non-ideal solution. The bonds are stronger. This is also right. Now come back. Solution B and C will follow Raoult's law. Solution B and C. They are non-ideal solutions. They do not follow Rolle's law, so this is ruled out. Okay, solution B will follow Rolle's law. That is correct. Solution B will give negative deviation from Rolle's law. Which is solution B? This one. What are they showing? They're showing hydrogen bonding. Because of this, they are showing positive deviation. So this option also is wrong. Solution C will show positive deviation. Solution C, what is it showing? It is showing negative deviation. So this is also wrong. So what is the correct option, students? Solution A, that is option B, is the correct answer. Option B is the correct option for this. Perfect. Let's see the next question. Let's go. KH for argon, carbon dioxide, formaldehyde, and CH4 are given here. All right. So KH value are given for all. What should I do? I have to arrange these gases in the order of increasing solubility. So first of all, let us write the clue which I have to remember before we go into the concept. First of all, the concept is higher the KH value, what will happen to the solubility? The solubility is lower the solubility. This is the concept. Next concept is what? Lower the KH value. Lower the KH value. What is the solubility? Higher is the solubility. Perfect. This is a concept, students. This is a concept. So remember. Now let us write the values and check. Let us go to the next page. How much is argon given? Argon KH value is given as 40.39. Is it right? Yes. Then carbon dioxide given is 1.67. Okay. Carbon dioxide given is 1.67. How much is formaldehyde given? Okay. HCHO given is 1.83 into 10 raised to the power of minus 5. How much is methane given? Methane given is 0.413. Okay, now they asked me increasing order of their solubility. Now, first of all, you have to remember, as I said, high increasing order solubility means the one which is having the one which is having the maximum solubility. See here, increasingly the one which is having maximum solubility should be there. So which is having maximum solubility? The one which has lower KH value. Among all this, which is having lower KH value, students, सबसे कम HCHO. Correct. Now सबसे ज़्यादा, which is having maximum, this one, because maximum KH means low solubility. See here, this is max KH, so low solubility. What is this? Minimum KH, so high solubility. They asked me to arrange in increasing order. So the remaining things I'm writing CO2, then CH4, and that's so simple as that. Easy, students, easy peasy. Let's go to the next question quickly. One more graph. For a binary solution, very important question this is. For a binary solution, ideal solutions, the variation in total pressure versus composition, variation in total pressure versus composition of a solution is given by the curves. Given by which curve? Which curve? Okay. So first of all, let us carefully understand the concept and do it. They said vapor pressure. So vapor pressure, how is it depend? First of all, what is binary liquid solutions? Nothing, students. Binary liquid solution means nothing. Binary liquid solutions are mixture of two liquids. Okay, let us write. Binary means two, mixture of two liquids. Two liquids, what are they? Both are completely miscible. Both are completely miscible in nature. Okay, both are completely mixing. This is done. Now they said one more thing, which graph is representing. I'll take out one more concept. Vapor pressure is directly related to the mole fraction. It is directly related to mole fraction in a binary ideal solution. This is binary solution. This concept you know, right? Mole fraction is ideal. Let me mark this and keep it. Okay, done. Now this concept is clear. Now I'll proceed. So in graph 1, the graph is increasing. In graph 2, it is not a straight line rather, okay, but it is starting from the initial point. All right, from the basic initial point. Now this is also decreasing. Now in D, it is again a straight line. So two are straight lines in this. Now I'll go to the concept using this. First of all, according to Raoult's law, okay, according to the Raoult's law, what is the concept, students? P is directly proportional to XA. P is equal to P naught A XA. Am I right? Done. Let us further expand. P is equal to X1 P naught 1 plus X2 P naught 2. Am I right, students? Right. Now, for the simplify, P is equal to 1 minus X2 P naught 1 plus X2 P naught 2. Correct? We very well know X1 plus X2 is equal to 1. This concept also we know. Now further, here what did we take? We have taken, in this case you see both the components are there. Px1 is there, Px2, both the solutes are there in this case. Now I'll write in those terms. Just check. I'm checking the first one. P is equal to, okay, P naught. I am writing the same thing in terms of x1 and x2. So can I write this as P naught 2 minus P naught 1? First concept, can I take x2 plus P naught 1? Same thing I have written in this term. Now you see, students, in this case, this is on the y-axis. Is it on the y-axis? See here, P is in the y-axis. Then this is equal to mx. This is mx, x value, plus c. This is a slope and this is the intercept. This is on the y-axis, this is on the x-axis. Let us see. This is on the x-axis. Perfect. And this is c. That's the intercept. Now let me write in terms of x1. P is equal to P naught 2 minus P naught 1. Take it x1 plus P naught 1. This is also same. Y is equal to mx, that is nothing but x1 plus c. So what is this and this, students? It's nothing but, and comparing both the equations, it is the formula for a straight line graph. Formula for a straight line graph, that is y is equal to mx plus c. So now if I have to go back and see, you only check which one is straight line. This is one straight line, this is one straight line. So here total vapor pressure and the composition of the solution will be a straight line, because the formula which we have deduced is it is similar to your straight line equation. So the graphs whichever are straight in nature, depending upon the conditions, it may be positive and negative. Okay, you may have positive values, you may have negative values based on your P naught values. Okay, P naught 1 and P naught 2. Because of this, it may be positive and it can be positive, it can be negative, but remember, it is always a straight line graph according to this. Correct na? Yes, easy, easy. Very good. Now let us go to the next concept. We have done very important MCQs. Now comes the short answer questions. So from here, students, I have given very short answers. Question is given to you, answer is given. Question, answer. Like that, all the questions and answers are given. For all the very short answers, you can directly study. Gradually, more questions and question and answers are given for your short answers. Please finish it off today only. From there, I have given all the 1 mark questions. How many questions are there? 1 to 20 questions are there here, and further going further, more answers are also here. So gradually 20 questions. Today is, what is your target, students? 20 questions is your target. Correct na? So what is it? Remember, today we have done almost, I think, 22 MCQs we have done. 22 MCQs we have done today, and I have given you short answer questions. Almost how many students? Let us count. Here we have your, okay, so 20 here and here, almost 1 2 3 4 5 6 7 8 9 10 11 12, almost or around. Okay, so how many did I give? Where did I write? This is a blank. Okay, I've written here. I'll go back to the page. Sorry, I'll go back. So I have done MCQs 22. I've given you short answers. Okay, very short answers, and short answers all are covered in this series. So series 1 and series 2, like that, we'll be doing many more. Practice it. Today your task is finish off the series. Finish series 1 and series 2 today only, and tomorrow morning get up early in the morning, students, and series 1 and series 2 get up early in the morning and study. 5 a.m. your 5 revision should be over. I'll meet you tomorrow. Bye bye. Signing off. Thank you so much. Your Vani ma'am. Bye.